Okay, here's the second lesson for working with exponent laws. The first lesson we introduced the main exponent laws and solved some simple problems involving them. In this lesson we'll solve some more complex problems where we simplify algebraic expressions using the exponent laws. So here's just a quick summary of the rules we looked at last lesson. The product rule tells us that when we multiply powers to the same base, you keep the base the same and you add the exponents. So x to the a times x to the b is equal to x to the a plus b. The quotient rule tells us that when we divide powers that have the exact same base, they go through the base of x, what you do is you keep the base the same, and you subtract the exponents. X to the a divided by x to the b is equal to x to the a minus b. Power of a power rule tells us that when we have a power of a power, so x to the a to the b, what you do is you keep the base the same and you multiply the exponents. And we also looked at the zero exponent rule, which tells us anything to the exponent of 0 is equal to 1. Okay? So the one rule that we didn't look at last time that we'll need for today is the negative exponent rule. So that tells us that if we have a negative exponent, that's equal to, so if I have x to the negative b, that's equal to the reciprocal raised to the positive exponent. So x to the negative b equals 1 over x to the positive b. Okay, so let's just quickly do a couple examples with that. So like I just said, any non-zero number raised to a negative exponent is equal to its reciprocal raised to the opposite positive power. So if I have x to the negative 3, that's equal to the reciprocal, 1 over x to the positive 3. If I have 5 to the negative 2, that's equal to the reciprocal to the positive power, so 1 over 5 to the positive 2, which I can simplify further to 1 over 25. And lastly, I have x to the 3 divided by x to the 5. Okay, so I need to use the quotient rule here, dividing powers to the same base, subtract the exponents. 3 minus 5 is negative 2. So I keep the base the same as x, and I subtract the exponents. 3 minus 5 is negative 2. But I can't have a negative exponent in a final answer, so what I need to do is I need to write that with a positive exponent by writing it as the reciprocal raised to the positive exponent. So 1 over x to the positive 2. Okay, so let's try a couple more examples here. If you want, pause it, try these couple examples. Okay, so now I will go through these with you. So x to the 5 divided by x to the 9. Quotient rule tells us that when we're dividing powers to the same base, you keep the base the same, subtract the exponents. 5 minus 9 is negative 4. But I can't have a negative exponent in my final answer. To make that positive, I write it as the reciprocal to the positive exponent, so 1 over x to the 4. Here, I have 6x cubed divided by 3x to the 7. So I have a couple things I have to do here. First thing I'm going to do is I'm going to simplify these coefficients. 6 divided by 3, I know what that is. 6 divided by 3 is 2. Now x to the 3 divided by x to the 7. Okay, so I'm dividing powers with the same base. I can simplify that. I keep the base the same, and I subtract the exponents. X to the 3 divided by x to the 7. So I do 3 minus 7 gives me negative 4. But I can't have a negative exponent in my final answer, so I need to write it as the reciprocal with a positive exponent. So you can think of it this way as well. Think of any numbers over 1. Right? So what I want to do is I want to take this x to the negative 4, move it to the bottom of the fraction, and that'll change the sign on the exponent. Okay? So let's do that. This gives us 2 over x to the positive 4. Don't forget that 2 is still up top there. Okay? Next question. Let's do this one here. This one doesn't have any negative exponents. But what it does have that's different than yesterday is that there are coefficients attached to these variables. So what I have here is 5 times x squared times 2 times x to the 7. Okay, so I have 5 times x squared times 2 times x to the 7. What I want to do, I want to, first of all, simplify the coefficients. I have a 5 times a 2. I could simplify that to 10. And now I have an x squared times an x to the 7. Those are powers of the exact same base. I can simplify those using the product rule by keeping the base the same and adding the exponents. 2 plus 7 is 9. Okay? So simplify everything you can. We can simplify 5 times 2 gives me 10, and I can simplify x squared times x to the 7 because those have the same base. By keeping the base the same, adding the exponents. Okay? So let's do the next one. And I put a little note here, this is an important part of exponent laws, okay? Exponent laws only apply to powers that have the same base, okay? So don't try and combine a squared times b cubed to like AB to the 5 or something, okay, they don't have the same base. These are not, A and B are not the same base, so we cannot simplify those any further together. But what we can do, we can notice I have an A squared here times, there's also a base with an A over here. I could simplify those together because they have the same base. First thing I'm going to do though, is I'm going to simplify these coefficients. I have a 2 times x squared times b cubed times 3 times a to the 6 times b to the 4. I can simplify 2 times 3, that's 6. Now I'm going to simplify powers that have the same base. I have an a squared here times an a to the 6. Keep the base the same, add the exponents, gives me a to the 8. And I also have a b cubed here times a b to the 4 here. Those are powers with the same base being multiplied together. The product rule tells me to keep the base the same and add the exponents. 3 plus 4 is 7. And that's as simple as I can make that. So I'm done. Next one. I have a power of a power. I have 5x cubed to the exponent of 2. What I have to do here, I have to remember to apply this exponent of 2 to the 5 and also to the x cubed. Okay, the main mistake is people forget to square the coefficient inside the brackets as well. So don't forget to do that. Square everything that's inside the brackets. Okay, so I need to square the 5. 5 squared is 25. And I also need to square the x cubed. That's a power of a power. The power of a power rule tells me to multiply the exponents and keep the base the same. 3 times 2 is 6. So it gives me x to the 6. And I'm done that one. That's as simple as I can make that. Next one, power of a power again. Don't forget to apply this exponent of 2 to everything inside the brackets, the x to the 4 and to the y to the 3. So x to the 4 squared, power of a power rule tells me to multiply the exponents, so it gives me x to the 8. And y cubed squared, multiply the exponents, keep the base the same, I have y to the 6. And that one's as simple as I can make it. Next question. Okay. So I put a little note here, remember the negative exponent law. Okay, first thing I always like to do is I like to simplify these coefficients if I can. So I have a 12 k squared m to the 8 divided by 4 k to the 5 m to the 5. I can simplify 12 divided by 4. 4 goes into 12 3 times exactly. So that works out nicely. Now, I can simplify other things. I'm going to look for powers that have the same bases. So I have a k squared up here and a k to the 5 down here. So I have a k squared divided by a k to the 5. Okay, so that's quotient rule. Quotient rule tells me to keep the base the same and subtract the exponents. 2 minus 5 is negative 3. I also have an m to the 8 on the top and an m to the 5 on the bottom. So m to the 8 divided by m to the 5. Quotient rule tells me to keep the base the same. Subtract the exponents. 8 minus 5 is 3. And don't forget, you can think of this as all being over 1. Now my final answer cannot have a negative exponent. So what I need to do to make that exponent positive, I need to take that power, move it to the bottom of the fraction, and that will give me the positive exponent that I'm looking for. So I'll rewrite this as 3m cubed over k to the positive 3. So that k to the negative 3, when it moves to the bottom of the fraction, it becomes k to the exponent of positive 3. Okay? There's another way that you could think of doing this question. So I'm going to erase this now. If this made perfect sense to you, do these type of questions this way. That's perfectly fine. I'm going to show you how I would probably look at doing this question. Okay? So what I have, I'm going to simplify some stuff up here. So I have 12 over 4. I'm going to simplify that. 12 divided by 4 is 3. Okay? 3 over 1. That's that in simplest form. Now, I have a k squared on top and a k to the 5 on the bottom. So what that really is, a k squared is k times k. And on the bottom, I have k to the 5. That means k times k times k. So I'm going to have 5 factors of k down here. Okay? I have 5 factors of k, and what's going to happen is 2 pairs are going to cancel, and I'm left with 3 k's on the bottom, so k cubed. Okay? So what's going to happen is 2 pairs of k's are going to cancel. So the 2 pairs, so the pair of 2 on the top is going to be gone, and on the bottom 2 pairs are going to cancel. So I'm going to take away 2 from that exponent of 5, and it gives me an exponent of 3. So I'm left with k to the 3 on the bottom, and the k's on the top are gone. Now I have an m to the 8 divided by m to the 5. 5 pairs are going to cancel. So all 5 on the bottom are gone. I'm going to take away 5 from the top pair. 8 minus 5 is 3. So I'm left with an m to the 3. So now, after doing all that simplifying, I can go right to my final answer. I'm left with a 3 on the top and an m cubed. And on the bottom, I'm left with, all I'm left with is a 1 times k cubed, which is just k cubed. Okay, so that's the exact same answer I had before. So it's just another way of looking at the problem. So do it either way you feel most comfortable with. I'll probably show both methods for the rest of the questions in this. Okay, next question. When you have a question that looks complicated like this, the first thing I would do is I would simplify the numerator and then simplify the denominator, and then see if anything else can be simplified. So let's just first look at the numerator and see if we can simplify it. So I have negative 2 times u times v cubed times 8 times u squared times v squared. First thing I'm going to do is I'm going to simplify the coefficients. So a bunch of things being multiplied together here. I know what negative 2 times 8 is. That's negative 16. So I can simplify that. Now I'm going to simplify other powers that have the same base. So I have a u times a u squared. I know a u, if I don't see an exponent, I know there's an exponent of 1 there. So I have a u to the 1 times a u squared. They have the exact same base. I can use the product rule and simplify that. Multiplying powers to the same base, you keep the base the same, add the exponents. 1 plus 2 is 3. I also have a v cubed times a v squared. Those have the same base, so I can simplify those. Keep the base the same, add the exponents. 3 plus 2 is 5. Now let's simplify the denominator. So I have a power of a power down here. So don't forget to apply this exponent of 2 to everything inside the brackets, to the 4, the u, and the v squared. So let's do that. 4 squared is 16. U squared is just what I said, u squared. And v squared squared, power of a power, multiply the exponents and keep the base the same. 2 times 2 is 4, so I have v to the 4. Okay? Now I'm going to simplify this. What I have, negative 16 divided by 16, that gives me negative 1. Okay? U cubed divided by u squared, 2 pairs are going to cancel, so take away 2 from that 3, I am left with a u to the 1. v5 divided by v to the 4, okay, 4 pairs are going to cancel. Take away 4 from that 5, I'm left with a 1. Okay, so that gives me negative 1. So everything on the bottom is canceled, so I'm left with a 1 on the bottom. On the top, I have negative 1, u to the 1, v to the 1. So just u, v. That's my answer for that one. Okay, so I'll show this without all this canceling involved here, in case that was confusing you. So I'll do this again without all that canceling. I'll just write it below. So I'm going to simplify the coefficients first. Negative 16 divided by 16 is negative 1. U cubed divided by u squared, dividing 2 powers with the same base. What I'm going to do is keep the base the same, subtract the exponents. 3 minus 2 is 1. If it's an exponent of 1, you don't have to write it. V to the 5 divided by v to the 4, keep the base the same, and subtract the exponents. Okay, that's what the quotient rule tells us to do. 5 minus 4 is 1. I don't have to write an exponent of 1. So there's my answer. Number 10. Let's attack this one the same way. Let's simplify the numerator if we can. We have a power of a power. Just don't forget to apply this exponent on the outside to everything on the inside. To the 3, to the m squared, and to the n. So that gives me, so 3 squared is 9. M squared squared, power of a power, tells me to multiply the exponents. 2 times 2 is 4. So it gives me m to the 4. And n squared is n squared. Okay, now let's simplify the bottom here. I have 2 times n times 3 times m squared times n. First thing I'm going to do is I'm going to simplify these coefficients. 2 times 3 is 6. Now I have, look for powers that have the same base. I have an m times an m squared. Remember, this m has an exponent of 1. M times m squared, multiplying powers to the same base. You keep the base the same and add the exponents. 1 plus 2 is 3. And I have an n times an n. So an n to the 1 times an n to the 1. Multiplying powers to the same base, keep the base the same, add the exponents. 1 plus 1 is 2. Okay, now let's simplify this. So I have 9 over 6 in simplest form is 3 over 2, because 3 goes into 9 3 times, and it goes into 6 twice. M to the 4 divided by m to the 3, keep the base the same, and subtract the exponents. 4 minus 3 is 1. I don't have to write an exponent of 1. N squared divided by n squared gives me n to the 0, which equals 1. Zero exponent law tells me anything to the exponent of 0 is 1. Okay, so I don't have to write times 1, because multiplying something by 1 doesn't change it. So you can think of these essentially as canceling out. Okay, so here's my final answer. So if you want to think of it the canceling way again, we can do that. So 9 over 6, 3 goes into 9 3 times, goes into 6 twice. M to the 4 divided by m to the 3. 3 pairs are going to cancel, so those are gone. And then take away 3 from that 4, I'm left with the 1. So you'll see on the top, I'm left with a 3m to the 1, so 3m. Over on the bottom, all I'm left with is a 2. Okay? And then these n squares cancel. Okay? 2 pairs cancel from the top and the bottom. Okay. What I want you to do is I want you to try the next couple on your own. So pause it right now. Try this one. Hopefully you can get the answer 5CD. Okay, hopefully you've had a chance to try that one. I'll go through the solution to it for you. So I'm going to simplify the top. I'm going to do a little bit less explanation this time. Okay, I'm going to simplify the top. I'm going to simplify the coefficients first. 5 times 4 is 20. Now what I'm going to do, I'm going to look for powers to the same base. I have a c cubed times a c squared. Product rule tells us to add the exponents. So c to the 5. I have a d times a d squared. Add the exponents. I have a d cubed. On the bottom, the denominator, I need to apply this exponent of 2 to everything in the brackets. The 2, the c squared, and the d. 2 squared is 4. C squared squared, power of a power rule, tells me to keep the base the same and multiply the exponents. 2 times 2 is 4. And d squared is just d squared. Let's simplify this. 20 over 4, okay, in simplest forms, is 5 over 1. Okay, 20 divided by 4 is 5. C to the 5 divided by c to the 4. Okay, 4 pairs are going to cancel, so those are gone. And take away 4 from that, I'm left with 1. D cubed divided by d squared, 2 pairs are going to cancel. Take away 2 from the 3, I'm left with d to the 1. Okay, so you could write your final answer here of 5CD. If you like doing it the other way, let me show you that way without doing all that canceling. I'll just write the answer below. So 20 divided by 4 is 5. C to the 5 divided by c to the 4 is c. Because dividing powers are the same base, you keep the base the same, subtract the exponents. 5 minus 4 is 1, so c to the 1. And d cubed divided by d squared, quotient rule tells us to subtract the exponents and keep the base the same, so I'm left with d to the 1. Okay. Next one, let's do this one here. So this one will, I'll let you try this one. So pause it now, try this, hopefully you can get this answer, and I'll go through how we got that answer. Okay, press pause. Okay, hopefully you've had a chance to try that. I'll show you how I got my answer here. Let's simplify the numerator. Apply that exponent of 3 to everything inside the brackets. The 3 of the x and the y. So 3 cubed gives me 27. X cubed is x cubed. And y cubed is y cubed. And on the bottom I have 9, x to the 4, y to the 4. So I'll go through the different ways that we could solve this one. I'll go through the canceling way, the first way. That's the way I like to do it. 27 over 9. 9 goes into 27 3 times, and 9 goes into 9 once. X cubed divided by x to the 4. So 3 pairs are going to cancel. So those 3 are gone. Okay, and take away 3 from that exponent, and I'm left with an x to the 1. Y cubed divided by y to the 4. 3 pairs are going to cancel. Take away 3 from that exponent, I'm left with 1. So what I'm left with on the top of the fraction is a 3. On the bottom, I'm left with a 1 times x to the 1 times y to the 1. So just an x, y. The other way you could do this one, if that way doesn't make sense to you, do it this way. So 27 divided by 9 is 3. Look for powers with the same base. So I have an x cubed divided by an x to the 4. They have the same base. I'm dividing them. I keep the base the same. And then what I do is I subtract the exponents. 3 minus 4 is negative 1. I also have a y cubed divided by a y to the 4. Dividing powers with the same base. Keep the base the same. Subtract the exponents. 3 minus 4 is negative 1. Now you can't have a negative exponent in your final answer, so what you want to do, think of this as over 1, and what you want to do is move the powers that have a negative exponent, move both of those to the bottom of the fraction, and that will make the exponent positive. So this will equal 3 over x, y. And both of those have a power of 1, even though you don't see it. Okay? So hopefully that made sense. Make sure you go to jensenmath.ca and try the worksheet. Make sure you can get the right answers. If you have any questions, let me know.